In the video on bond line structures, we started with this Lewis dot structure on the left, and I showed you how to turn this Lewis dot structure into a bond line structure. So here's the bond line structure that we drew in that video. Bond line structures contain the same information as a Lewis dot structure, but it's obviously much easier, much faster to draw the bond line structure on the right than the full Lewis dot structure on the left. What about three-dimensional bond line structures? So how could you represent this molecule in 3 dimensions using a flat sheet of paper? Well, on the left here is a picture where I made a model of this molecule, and this is going to help us draw this molecule in 3 dimensions. So we have a flat sheet of paper. How could we represent this picture on our flat sheet of paper? Let's start with the carbon in the center. So that's our carbon in magenta. So that's this one on our Lewis dot structure, this one on our bond line structure. Well, the carbon in magenta is sp3 hybridized, right? This is sp3 hybridized, so we would expect tetrahedral geometry around that carbon. And if you look at that carbon on the picture here, you can see that this bond and this bond are in the same plane. So if you had a flat sheet of paper, you could say those bonds are in the same plane. So a line represents a bond in the plane of the paper. Let me go ahead and draw that. So this is the carbon in magenta, and then we have these 2 bonds here, and those bonds are in the plane of the paper. Next, let's look at what else is connected to the carbon in magenta. Well, obviously there is an OH, so let me go ahead and circle that. So there's an OH, we can see there's an OH here. And then the OH in our picture is coming out at us in space. So hopefully you can visualize that this bond in here is coming towards you in space, which is why this oxygen, this red oxygen atom, looks so big. So this is coming towards you. We would represent that with a wedge. So let me go ahead and draw a wedge in here. And a wedge means that the bond is in front of your paper. So this means the OH is coming out at you in space. So let me draw in the OH like that. Now let's look at what else is connected to that carbon in magenta. We know there's a hydrogen, right? We didn't draw it over here, but we know there's a hydrogen connected to that carbon. And we can see that this hydrogen right here, let me go ahead and switch colors. This hydrogen is going away from us in space, right? So this bond is going away from us in space or into the paper, or the bond is behind the paper. And we represent that with a dash. So I'm going to draw a dash here showing that this hydrogen is going away from us. So we're imagining our flat sheet of paper and the OH coming out at us and that hydrogen going away from us. All right, next let's look at the carbon on the left here. So this carbon in blue. So that's this carbon, and I'll say that's this carbon over here on the left. So we know that this carbon, we can see that this bond and this bond are in the same plane. All right, so let's go ahead and draw in the carbon. So the carbon that I just put in is the carbon in blue. And this hydrogen over here on the left, right, this bond is in the same plane. So I'm going to draw a line, right, representing the bond is in the plane of the paper. And so we have a hydrogen right here. What about the other 2 hydrogens? Well, let me highlight those. So this hydrogen, hopefully you can see that this is coming out at us in space. So we represent that with a wedge. So we draw a wedge right here, and then we draw in the hydrogen. So the bond is in front of the paper. The bond is coming towards us in space. And then there's another hydrogen bonded to the carbon in blue, and my thumb here is blocking it a little bit, but hopefully you can see that's going away from us in space. Right? So this hydrogen is going away from us in space. So the carbon in blue, right, is also sp3 hybridized. Right? This carbon is sp3 hybridized. We would expect tetrahedral geometry around that carbon. And then finally, let's look at the last carbon. So this carbon right here in red. So that's this one right here and this one right here. This carbon is also sp3 hybridized. So we expect tetrahedral geometry. And if we look at this carbon, let me use yellow again. This bond and this bond are in the same plane. So let's draw in the carbon in red, and we can draw in the hydrogen right here in the same plane. And then let's visualize the other 2 hydrogens. Right? So this hydrogen is coming out at us in space, so we represent that with a wedge like that. So we have a hydrogen coming out at us in space, and this other hydrogen here is going away from us in space. So it looks a little bit smaller, so that's a dash right here. All right, so we've drawn everything out, and notice when you have a tetrahedral carbon, an sp3 hybridized carbon, you have this pattern. You have this pattern of two bonds in the plane of the paper, and one wedge and one dash. So that's how we're representing our tetrahedral geometry around those carbons, around those sp3 hybridized carbons. All right, it's usually you don't see the hydrogens drawn in on one of these, so we could simplify our three-dimensional bond line structure even more. We could just say we have an OH coming out at us in space. So I draw a wedge right here, right? And you could draw it like that, which is implied that there's a hydrogen going away from you. So if you draw an OH coming out at you, that implies that there is a hydrogen going away from you in space. So three-dimensional bond line structures are an important skill to be able to visualize. For this molecule, it's not so important that the OH is coming out at us. That's just how I drew it here, because that's what it looks like in the picture. But later in organic chemistry, it's very important to understand what's coming out at you in space, what's going away from you, what does the molecule look like in 3 dimensions. And bond line structures, three-dimensional bond line structures, allow us to visualize that. Model sets help, so you should definitely purchase a model set at this point in your study of organic chemistry, because it's going to help you a lot later in the course. On the left is the Lewis dot structure for acetone, and we could turn that into a bond line structure really quickly. So here is the bond line structure for acetone. I could put in lone pairs of electrons on the oxygen, or I could leave them off. I'll just go ahead and put those lone pairs in there like that. What would be a three-dimensional bond line structure for acetone? Well, on the left here is a model of the acetone molecule, and hopefully you can see that these atoms right here, these atoms are all in the same plane of the page. And so is oxygen, actually. So is this oxygen here. And it's a little bit easier to see in the picture on the right. So in the picture on the right, so these are the atoms that we were just talking about. So these are all in the same plane. So if you can, hopefully you can visualize like a sheet of paper. So let me see if I can sketch in a sheet of paper right here like this. And so all those atoms are in the same plane of that paper. So we could draw that in like this. We could have our carbons over here like that, our 3 carbons. And according to this picture, these 2 hydrogens here, so if we're trying to copy this picture, those 2 hydrogens are in the plane of the page. And so is this oxygen. So this oxygen right here is in the plane of the page. So we'll draw it in there like that. I'll go ahead and put in lone pairs of electrons on the oxygen. All right, let's focus in on the carbon in the center for right now. I'm not done with my three-dimensional bond line structure. I just want to point something out right here. So this carbon right here in magenta, right, is this carbon, which is this one, just it's hiding back here. But we know that carbon is sp2 hybridized, so we would expect trigonal planar geometry around that carbon. So trigonal planar, right, we would expect everything to be planar. So the atoms connected to the carbon in magenta, we would expect those to be in the same plane. And it's a little bit easier to see that on the right here. So these carbons and this oxygen, right, those are all in the same plane. We have sp2 hybridization. All right, let's now look at the other carbons. So let's do blue here. So carbon on the left right here, I'm saying that's this one. This carbon is sp3 hybridized, right? sp3 hybridized, which means tetrahedral geometry. We would expect tetrahedral geometry around that carbon. And so we have these 2 bonds in the plane of the page, right? And then this hydrogen is coming out at us in space, and then this other hydrogen back here is going away from us in space. So on our three-dimensional bond line structure, we could draw a hydrogen coming out at us in space, right? So that's a wedge, and then a hydrogen going away from us in space, so that would be a dash. And then the carbon on the right, which I'll make red, this is also sp3 hybridized, so we would expect tetrahedral geometry. And we can see this bond is in the plane, this bond is in the plane of the page, and this hydrogen is coming out at us, and then this one's going away from us. So we could complete our three-dimensional bond line structure over here on the right by showing a hydrogen coming out at us and a hydrogen going away from us in space. All right, if we look at this picture on the right again, and we've already visualized our flat sheet of paper. Imagine your eye is right here. Imagine your eye is looking down on your flat sheet of paper. So your eye would see, let me use dark blue for this, these two hydrogens coming out at you in space, right? So that's these two hydrogens coming out at you. So hopefully this just helps you visualize it a little bit better. And then your eye would see these two hydrogens, these would be behind the plane of the paper, right? So that's going away from you in space. So the hydrogens in green would be going away from you, so we represent that with a dash. So hopefully that helps you visualize it a little bit better here. Now for acetone, you normally wouldn't draw out a three-dimensional bond line structure, right? There's not much of a point to drawing the structure on the right. I just did it to help you visualize things a little bit better and to contrast an sp2 hybridized carbon with an sp3 hybridized carbon and to think about what it looks like in 3 dimensions. So pretty much for something like acetone, you're going to stick with the bond line structure right here and not make it three-dimensional. But I think it is important to think about these things and to make these molecules, build them yourself, visualize it, and understand this concept before you move on to other parts of organic chemistry.